So, electronics. Video 1. Electrons. So, electrons. Electrons are one of three particles we'll be looking at when we talk about atoms, which can be thought of as the building blocks of our electronics. Atoms are made of protons, neutrons, and electrons. Protons and neutrons sit together in the nucleus, or central part of the atom. They form the core of the atom and aren't very mobile. In fact, in our electronic work, they are effectively immobile, and we won't really talk about them much. Electrons, on the other hand, make up the outer shells of the atom. They are much more mobile than protons. So mobile, in fact, that simply putting atoms side by side can allow electrons to travel between them. That's why we talk about electronics, not protonics. As a field, we are concerned with the movement of electrons. But electrons aren't just free to move around as they please, and different materials have different ease of movement associated with them. In this case, our electron has found its mobility impaired by some tacks. We call Eve's tacks and new tires an insulator. Insulators are materials that prevent the flow of electrons, while conductors permit the flow of electrons. These are general classes, of course, that are sufficient for now. But what makes a good conductor? That's pretty complex and beyond the scope of simple electronics tutorials, but as a rule of thumb, think of atoms as having seats for electrons, like a fleet of really small buses. The buses, in atomic terms orbitals, fill up in order, and the last electrons on the bus are the first to get off. That is, the valence electrons are the ones that are first to react with other atoms. But from some seats, it's easier for electrons to get off the bus, so to speak, or move to another atom. If the last seats to fill up are these seats, the valence electrons are considered to have low ionization energy. In English, that means that it doesn't take much energy to get an electron to move. For the bus analogy, think of these seats as very uncomfortable. The electrons don't need much encouragement to leave this atom and go to another atom in search of more comfortable buses. What does this mean to you? Well, if you look at the periodic table, you can see that this is pretty much organized along this orbital, or bus scheme. Atoms towards the left are metals and are in general better conductors. Atoms toward the right are nonmetals and are in general insulators. Again, please keep in mind that this is a dramatic oversimplification and is only meant to serve as a rough guide. Oh, and one last thing before we close up this video. Pretend you have a sheet of metal. We know that the valence, or first to react, electrons are easily motivated to move from atom to atom. It turns out that the thermal energy at room temperature is more than enough to motivate some electrons to move spontaneously. But this motion is very small and undirected. It's not useful to basic microelectronics work. We'll mostly be concerned with directed electron motion. Motivating electrons is what will be covered in the next video, and then we can start looking at how we will get things done. And keep those random facts we said weren't important under your hat. We may get back to them eventually and make them useful. That's all there is for this video. Keep in touch.